Hello everyone, I am your instructor, Wang Shengda. Before we begin studying polymer physics, I will introduce the nature, main content, and basic concepts of polymers. In this lesson, you will learn basic polymer concepts such as monomer, repeating unit, and degree of polymerization, and how polymers are classified by use. You will be able to determine the monomer and repeating unit based on the polymer's structure. You will also be able to identify the use of a polymer by its product. Polymer physics is a compulsory course for polymer-related majors. This course covers polymer structure, polymer solutions, polymer thermal motion, polymer mechanical properties, polymer rheological properties, and polymer electrical properties, making up 6 main sections. This will help students understand the relationship between polymer structure, molecular motion, properties, and applications. It will also lay a necessary foundation for students' future studies in polymer synthesis, modification, and processing applications. The 6 sections of the course content are as follows. Section 1, Polymer Structure, including the structure of polymer chains, the aggregated structure of polymers, and their impact on polymer properties, among other topics. Section 2, Polymer Solutions, including the molecular weight of polymers and its distribution, the solubility characteristics of polymers, and solvent selection methods. Section 3, Polymer Thermal Motion, including the characteristics of polymer thermal motion, the 3 mechanical states of polymers, and several characteristic temperatures. Section 4, Polymer Mechanical Properties, including basic concepts in material mechanics, stress-strain curves, polymer yield and fracture, and factors influencing the tensile strength and toughness of polymer materials. Section 5, Polymer Rheological Properties, including the rheological behavior of polymers, flow mechanisms, and the elastic effects of melts. Section 6, Polymer Electrical Properties, including the dielectric properties and conductivity of polymers. After studying this course, you will be able to analyze the basic chemical structures of commonly used polymer materials, the various properties of polymers and their relationship with structure, and you will be able to conduct a preliminary analysis of phenomena occurring during the polymer molding process. You will be able to effectively absorb new technologies and knowledge, analyze and solve practical problems effectively, and you will be able to search for professional information such as data and literature. Next, we will study the basic concepts of polymers. There are 4 terms that can refer to compounds with a high relative molecular mass. These are polymer, polymer, high polymer, and macromolecule. Polymer, polymer, and high polymer all translate to polymer in English. They all mean exactly the same thing. They refer to compounds or materials with a high relative molecular mass, whose structure is primarily composed of repeating units derived from molecules of relatively low molecular mass. Macromolecule only refers to molecules with relatively high molecular mass or molecular weight, without any additional constraints on the molecular structure. In this course, we will use polymer, polymer, or high polymer to refer to compounds with a high relative molecular mass, and will not use the term macromolecule. According to the relative molecular mass, it is generally defined that a relative molecular mass less than 1,000 is considered a low molecular or small molecule, and greater than 10,000 is considered a polymer. Those in between are referred to as oligomers. Next, we will take polyvinyl chloride as an example to study the basic concepts of polymers. Monomer refers to the small molecule used to synthesize the polymer, which is the raw material. For example, the raw material for synthesizing polyvinyl chloride is vinyl chloride. Vinyl chloride is the monomer of polyvinyl chloride. Repeating unit refers to the smallest repeating unit in a polymer. Degree of polymerization refers to the number of repeating units, denoted as dP. Since polymers are composed of many simple but identical repeating structures, the full structure is not written out when representing the polymer structure. Instead, square brackets or parentheses are added based on the smallest repeating unit, and the degree of polymerization is indicated. Polymers can be classified into 6 categories based on their use. Plastics, which use polymers as the base material with the addition of other additives, such as plasticizers, lubricants, fillers, antioxidants, etc., resulting in polymer materials that can be processed plastic alloy, such as pipes, joints, suitcases, rubber. Polymers are used as the base material, with appropriate types and amounts of additives added, such as vulcanizing agents, vulcanization accelerators, anti-aging agents, fillers, etc., processed to make them moldable. After heating and pressurizing cross-linking, they become highly elastic materials, such as inflatable boats, tires, fibers. Polymers are used as the base material, with appropriate additives added, such as solvents, anti-static agents, softeners. Polymer materials that can be drawn into fibers after formulation, such as clothing. Coatings are polymer materials applied to the surface of objects to form a tough film that serves decorative and protective purposes. Adhesives are polymer materials with good bonding properties, capable of bonding two identical or different objects together. Functional polymers are those with reactive functional groups on the main chain and side chains. They have reversible or irreversible physical functions or chemical activity. In this lesson, we studied the definition of polymers, the concepts of monomer, repeating unit, and degree of polymerization, as well as the classification of polymers by use.